Welcome to the Global Site Engineering channel. Today, we're diving deep into one of the most widely used materials in the oil and gas sector. Carbon steel. We'll cover its types, uses, welding methods, mechanical behavior, and quality control processes, all in a simple Q&A format. If you're a piping engineer, QA/QC inspector, preparing for a construction project interview, this one's for you. What is carbon steel? Let's start with the basics. Carbon steel is a type of steel where carbon is the main alloying element. Why do we use it in oil and gas? Because it offers high strength, is affordable, and easy to fabricate. You'll commonly see it in piping, pipelines, pressure vessels, structural steel, and casing or tubing. Types of carbon steel. Carbon steel isn't just one material, it's divided into types based on carbon content. Low-carbon steel, with less than 0.3% carbon, is soft, ductile, and great for tanks and structural parts. Medium-carbon steel is stronger and used for piping and flanges. High-carbon steel is very hard but brittle and rarely used in pipelines, more suited for cutting tools and wear parts. Limitations of carbon steel. Now let's talk about the drawbacks. Carbon steel is prone to corrosion, especially in sour environments with hydrogen sulfide. At low temperatures, it becomes brittle. And at high temperatures, it loses strength and may deform over time, a phenomenon called creep. To overcome these, we can use internal coatings, corrosion inhibitors, or upgrade to stainless steel or CRA materials. Corrosion protection is critical. We use external coatings like epoxy or polyethylene. Cathodic protection, either sacrificial anodes or impressed current systems, helps prevent electrochemical corrosion. Inside the pipe, we may apply epoxy linings or chemical inhibitors. And for sour service, we always refer to NACE MR175 standards to ensure material compatibility. Relevant standards. What standards do we follow for carbon steel? Here are a few key ones. API 5L for line pipes, ASTM A106 for seamless high-temperature service, SME Section 2 Part A ferrous material specifications. Mechanical perspective. Why is carbon steel so widely used? It's strong enough, cost-effective, and corrosion can be managed externally. However, its mechanical properties do change with temperature. At low temperatures, it can become brittle. At high temperatures, it weakens, which can be dangerous in long-term service. Welding processes. Welding carbon steel. Common methods include GA and GTAW, especially for root passes. But there are challenges, like hydrogen-induced cracking, poor toughness in the heat-affected zone, and defects like porosity or slag inclusions. To prevent these, always use preheating, controlled heat input, and low hydrogen electrodes. Why preheat? It helps reduce the cooling rate after welding, lowering the risk of hydrogen cracking. It also improves ductility and reduces internal stress in the weld area. QC weld inspection. Quality control is a must. For carbon steel welds, we use visual testing for surface flaws, radiography for internal defects, ultrasonic testing for volumetric flaws, magnetic particle testing for surface and subsurface cracks. Penetrant testing is less common here, mostly used for non-ferrous materials. QC documentation. A good QC record includes the WPS Welding Procedure Specification, PQ Procedure Qualification Record, Welder Performance Qualification, Material Test Certificates, and fit-up and dimensional reports before and after welding. Post-weld heat treatment. Post-weld heat treatment, or PWHT, is used to relieve residual stress and improve toughness. It's required when welding thicker materials, high-carbon steels, or when codes like ASME B31.3 mandate it due to toughness or hardness concerns. So to wrap up, carbon steel is tough, versatile, and budget-friendly, which is why it's everywhere. Its limitations, like corrosion or brittleness, can be handled with the right precautions. And with proper welding, inspection, and material selection, carbon steel components can perform safely and reliably in even the harshest environments. Thanks for watching. If you found this video helpful, like, share, and subscribe for more engineering content. Drop a comment if you'd like us to cover a specific topic. See you in the next video, and stay safe out.